Here we go. I'm going to try to finish 10.2 somewhat rapidly, but it's a long section. All right, find the 2 points that define the lattice rectum and graph the equation. So they're giving me some information. Vertex 0, 0, axis symmetry x-axis contains that point. All right, let's do it. So I'm going to draw. You remember, you always want to get a picture. That's just so helpful. Get a picture. So get a picture. The vertex is 0, 0. What does that mean when it says vertex 0, 0? That's origin, and that's the center. Vertex is their word for center, huh? So that's the center of the U-shape. That's the middle of the U-shape. When I say center, that might be confusing. That means that's the anchor. Is that a better word? In other words, either the U-shape sits like that, or maybe it sits like that, or maybe the thing's going to the right or the left. Whatever. 0, 0 is the vertex, which is the anchor for the U-shape. The focus is somewhere inside, but we'll get to that in a minute. Anyway, so the vertex is 0, 0. The anchor is 0, 0. Does this thing go up, down, right, or left? Well, let's come back to that. Let's do this point. How about the point 3, 4? Where's that? Remember, the first number is x, second number is y. First number is over. X-axis is over. Y-axis is up. So over 3, 1, 2, 3, up 1, 2, 3, 4. There it is. Over 3, up 4. That point, that dot, it contains it. Meaning the U-shape hits that point. Does that make sense? It doesn't miss it. It hits that point. So now do you know whether it's up, down, right, or left? The answer is no, we don't know. It could be up. It might be up. It could be going like that and you hit that point, you know. Or, what else could it do? It could be going to the right and hitting that point, couldn't it? We don't know. But we have to look at this fact to help us know. So everybody see why we need one more fact? It could be up or right. Hitting that point 3, 4. So which one is it? Well, the axis of symmetry is the x-axis. What is axis of symmetry? Axis that goes through the middle. Remember, symmetry means same. The line that goes through the middle of it is the x-axis. The x-axis goes through the middle of it. So which way is this thing going, up or right? Right. It's going to the right. Everybody see that? Right? Because the x-axis, whoops, I just erased the x-axis. The x-axis spears through the middle of it. So it must be going to the right. That's why they told us that. It's going to the right. Okay, now, then that's one of the most, almost the most important thing for a problem is to know which way it's going, up, down, right, or left. That's what makes problems challenging. You can go 4 ways. So now can you write the equation? The basic equation for the parabola. So the direction is the what in the equation? The direction becomes the what in the equation? So it's going to the right, which is positive x, right? To the right is the positive x-axis. It's going to the right. And that is the what? First power letter or second power letter in the equation? First power letter, right? That's the right side must be positive 4ax. So this other side must be y squared. See how I came up with that? The direction it's going is the first power letter. Always. And you're going to put those 4 things on your 3x5 card anyway, right? Those 4, you know, the 4 different directions. Remember that, how we talked about that? Oops. Uh-oh. Come on. What? Having trouble here. There's a little thing here. Remember the up, down, right, or left? That'd probably be helpful. So if it goes up, that's a positive y, so that's x squared is positive 4y. If it goes down, that's x squared, that's the negative y direction, so negative 4ay. If it goes right, that's the positive x, so that's y squared is positive 4ax. See the first power? And if it goes left, that's the negative x direction, so negative 4ax. So see how the first power letter always tells the direction, right? Positive y to the first, up. Negative y to the first, down. Positive x to the first, right. Negative x to the first, left. All right, so you'll have that in your 3x5 card. So coming over here, so as soon as we go right, we go, okay, it's y squared is positive 4ax. Good. Now what, though? I want to come up with the equation. When somebody says in a math problem in any class, in any math class, come up with the equation, Are you familiar with what that means? When they say find an equation, they mean only letters are x and y. They mean they want you to find everything except x and y. So notice I got to find a. See what I'm talking about? Long story short, they're saying find a. Because once I've found a, then I'll have the whole equation with x and y. That makes sense? That's what they always mean in any math problem when they say find the equation. They'll say that a lot in calculus and other classes. They mean, hey, get all the other letters discovered so you just have x and y. That's what an equation is, right? Just x and y. Okay, so how do I find a? That's what they want. Yeah. This point right here, this is x, this is y. It's on the graph. Whenever you have a dot on a graph, you just plug it in, don't you? So x is 3, y is 4. Exactly. So 4 squared is 4a times 3. 16 is 12a. I can solve for a. How do I solve for a? Divide by 12. What is that? Was it, I guess you could just divide by 4. Top and bottom, what's that, 4/3? A is 4/3. So we got a, which means we have the equation. And we run out of room to come over here and write it. What's the equation then? The equation is y squared is positive 4ax, so y squared is positive 4ax. But now I know what a is. What's a? 4/3. How we doing? Just making sense? Just out of the way here. So this is 4/3. So what happens then? That's y squared. This is 4 over 1. 16/3 x. Y squared. It's c. We're done. Did you all track with that? Did I go too quick there at the end? Is that making sense? What happened? So I found out it went to the right because the x-axis was the axis of symmetry. So I wrote the equation with positive x to the first, to the right. I plugged in the point 3, 4. 3 for x, 4 for y. Solve for a, 4/3. And then started the equation. See how I used the equation twice? Once to find a, second time plug in the a. There's my equation. See how that works? So we use the equation twice. Once plugging in the point and finding a. And then once you have a, plug in the a. There's the equation. Anything I can answer about that? Are we good? So we have the, let's finish this up. So we have y squared is, what was it? It was 4 times 4/3. So I'm going to leave it this way so I can tell what the a is. Right? That's where we got to? You with me? Here we are. Y squared is 4 times 4/3 times x, right? So here we go. 4 times 4/3 times x. So there's the equation. Can I graph that thing and find the lattice rectum points? Yeah. We basically have the graph almost done. So the graph will be, it goes to the right. What is the 4/3? That's the a, which is how far to the focus point, isn't it? You with me? So that means this is over 4/3. Okay, great. So what are the lattice rectum? Remember what the lattice rectum are? 2a. Here, and yeah, they're double that. So 2 times 4/3, which would be 8/3. And this is down 8/3. So this is over 4/3, up 8/3. And this is over 4/3, down 8/3. There are the lattice rectum points. No, I'm done. Question, Erica.
So A is the distance from the origin point?
Yeah, well, not from origin, but from the wherever this is, because sometimes they'll move the parabola somewhere else. It's the distance from the middle of the parabola. Yeah, so A is always how far from the middle of the parabola to the focus. Good question, right? So that's what A is. A is always, let me put it back on here. A is this. This is the focus. A is always how far from the middle of the parabola to the focus. And 2A is always how far to the lattice rectum points at the focal depth. The lattice rectum points are always located at the focal depth. Right? You go out to the focus and then up and down, double focal
Look at the focus point.
step. The A, double the A. Is that good on that?
2A. That's an A. Go to.
So that's how you find those lattice rectum. They're always at the focal depth twice. Lattice rectum are always twice A. All right, we better keep moving. Let's try this one. This one's tricky. Did I talk about a directrix line, what it is? Say yes, I'm saying?
Oh, it's the line behind.
It is. Did I talk about that?
Yeah, you mentioned.
Okay, it's the line behind. I should probably say more. Yeah, so start with, go ahead and start with the focus. And just put that focus and that line on a graph. How about that? Start with that. That'd be good. Make sure you can do that. And then we'll say more. So focus is back 4, down 2. So this is x is 6. This is back 4, down 2. We good so far. So this is the focus point, and this is the directrix line. Now, it's a line, that's why I put a dot line. So I haven't drawn anything about directrix lines or anything? Well, here, let me just draw a little bit. So basically, if you have a parabola, let me just show you. If you have a parabola, for example, that goes up, then the focus point is always inside. It's like on a satellite dish on somebody's roof, it's the receiver inside. Or on a headlight, it's the little lamp inside. It's right at the focal point. So it's always inside. Well, the directrix line is behind the shape. It's like a director behind the scenes directing the actors for the movie. That's what the directrix line does. It sits behind the shape, and it's the same distance. You know how the focal point is A away? Well, the directrix line is negative A. It's the opposite. Same distance, opposite direction. That's always where the directrix line is. So then if the shape goes, like, say, down, then the focus point will be down, and the directrix line will be back here. Same distance. Right? So the center of the parabola is always right in the middle of the focus and the directrix. They are same distance away on each side. So if the parabola is going to the right, the focus will be inside, and the directrix will be behind. If the parabola is going to the left, the focus will be inside, and the directrix will be behind. Get the idea? So the directrix is always behind the scenes, directing the parabola. The focus point is inside of the parabola. And they're the same distance away. In other words, it's always A one way, A the other way. To the directrix and the focus. They're always A away. Hey, I haven't said anything at all about what it even is, and I just never have time, but I don't want it to be magic. So let me say a couple words. Like, what is it? Like, what is that directrix line? What is that focal point? What do they have to do with this parabola? And where did that crazy parabola equation come from anyway? I just wrote it on the board like it's magic. You know, why has it got a 4 in it? Like, where did all that come from? Well, it all came from the idea that if you take a line, let's just say you take a line, that's the directrix line, he's going to direct us, and you take a point, the focus point, and you ask the question, what are all the points equidistant from the directrix line and the focus point? This is the directrix line. So all points, let me write out what I just said, all points that are equidistant is what I said, all points that are equal distances from the directrix line and focus point. So let's find, so remember, a big graph is like, it's like that old toy, the Light Bright. Remember the Light Bright where you put different little lights in the light? That's kind of like, or it's like pixels in our modern age with digital. Just imagine a bunch of pixels up there. Which ones get to light up? Which ones get to light up? That'll produce the graph. Well, how do you know if a light, a location, gets to light up, gets to be part of the graph? Well, is it a point that is equal distance from the directrix line and the focus point? Let's pick one, like this one. That's for sure equal, that's right in the middle, in other words. What are all the points right in the middle? Maybe that's a better way to say it. It's not quite technically right, but I think you get the idea. Right in the middle, right? That's one dot, we're going to get to more. But that's one dot, wouldn't we all agree, that's right in between the directrix line and the focus point. How far is he from the directrix line? However far he is, he's the same distance from the focus point. At least, sort of on my picture. It looks a little shaky. But maybe I should move this over a little bit. There, about right there. There we go. He's right in the middle, right? He's one dot right in the middle of those two. Okay, great. So what? Well, let's find some more dots. What's another dot that is right in the middle? Well, could I just do any dot on this line? Are all the dots on that line right in the middle? No. No. Let me show you. How far is this dot from the line? Well, that. How far is he from the focus? Further. Further. Not equal. So he's not in the graph. No thank you, no thank you, no thank you. They don't get to light up because they are not the same distance from the line and the focus point, are they? They're further from the focus point. All of those have a longer trip to make to the focus point than they do to the directrix line, don't they? Right? Remember, how far you are from a line always means straight at the line, doesn't it? Where's the point? You got to go all the way, which is further. See how those would not be part of our graph? Only this one, and then we'll get some other dots too in a minute. But nothing else on that straight line is going to be same distance from the dotted line and the focus point. They're all further away from the focus point than they are from the dotted line, aren't they? They're not equal distance. Well, okay, say like this dot is further away, right? He's got a longer trip to make to the focus point than he does to the directrix line. How could I move him to make him have the same distance from the line? Which way do I need to move him? Do I need to move him to the right or to the left to make him have equal distance from the two? To the right. He's got to go like over here a little bit, doesn't he? So that, maybe that's too far, but he's got to go a little bit to the right so that his distance from the focus and his distance from the directrix are the same. Well, that's what the parabola does. The points go a little bit to the right. Get the idea? All the dots that fit the condition that they are same distance, all these dots are same distance from the dotted line as they are from the focus point. All the dots that have that true quality, they're same distance from the dotted line, the directrix line, as they are from the focal point. They make the parabola. That is the parabola. That's what it is. It's the set of all points that are equal distance from the focus point and the directrix line. Focus point and the directrix line together make the parabola. That's what they do. So now, I still didn't tell you where the 4ay and, well, this one would be x, isn't it? Positive 4ax and all that come from, because we don't have time for all that. It's a little bit harder math. It's not that hard. You could understand it, but it'd be a little messy and it's not required. But I would greatly enjoy doing it with you. If you want to see some higher math, come by my office hours. I'd be glad to show you how they basically took this idea and derived this equation. If you do some math, some algebra, you can show that all the points that fit the condition of being same distance from the dotted line and the focus point end up fitting that equation. That's where the equation comes from. All right, well, that's enough of the backstory. Let's go forward. So with that in mind, let's go forward to where were we? I'm getting lost. This problem. Here's where we are. So we're working on this problem. Back to this problem now. So they're giving us a directrix line. They're giving us a focus point. And so next, and that's all they're giving us, and they want us to find everything else. Can you find the center dot? Can you find the middle of the U shape of the parabola? Well, yeah, it's got to be right in the middle of this focus and this dotted line, doesn't it? So first off, it's got to be somewhere on this line that's down 2. Wouldn't you agree with me? It's got to be at that level somewhere. And it's got to be right in the middle of -4 and +6, doesn't it? On the line down 2. Does everybody see that? So somewhere on this line will be the middle dot. Somewhere down to, right in the middle between -4 and +6. So how do you find the middle of -4 and +6? How do you find the middle of two numbers? If you get a 90 on one exam, on a 70 on the other, how do you find the middle of those two? Yeah, add and divide by 2. That's called averaging. You know how to find the middle of two numbers, huh? You just add them and divide by 2, right? So if I take those two numbers and I add them and divide by 2, I'm going to get, what, 2 over 2, 1? So +1, yeah, that's the middle of -4 and +6. It's 5 away from each of them, isn't it? See how it's 5 that away and 5 that away? So +1 is the middle, but the dot's actually right there because it's got to be lined up with the focus point, doesn't it? So the actual center dot is over 1 down 2. There's the middle of the parabola. It's got to be lined up with the focus. There's the center, or what they call the vertex of the parabola. Which way is this parabola going? Up, down, right, or left? Left. Going to the left, because the focus is always inside, huh? And the directrix is behind it. Good. See how we're piecing this together? Okay, now they want the rest of the equation. Can you do that? Let me let you do that part. I bet you can do it from there. So write the equation, you get more out of it. You do it yourself, so we can use some time. Feel free to check those around. Saves files, and that's the work. We good? You guys getting that? What, so the first thing to write is like is this, like, which of these four is it? It's going left, so it's this one. Y squared is -4x. I'll have that in 3x5 card. So y squared is -4ax. Let's start there. I'm going to get this stuff out of the way if I can. So be y squared is -4ax. Okay, but the center is not 0, 0. Right? All these are centered at the origin, aren't they? These are all centered at the origin. So ours is centered here, not the origin. So what do you do with the center? Remember, it's opposite, opposite. So this is the x and this is the y, but you got to put opposite, added or subtracted, next to x and next to y in parentheses. Remember that? So the y will become y, what? Opposite of -2? +2 squared minus 4, opposite of +1 for x, -1. Everybody good so far? So I adjusted the center, since the center is not the origin. And the only other thing I gotta do is gotta find a. Then we'll have the equation. Remember, an equation means just x and y, no other letters. So all I gotta do now is find a. My last task, find a. How do you find a? Let me give you a second. So how do we find A? What is A? A is how far from the middle to the focus. How far is that? 5. And it's just a distance. You don't have to go -5, +5, whatever. It's just 5. So you just put in A is 5. So this will be -20. X minus 1. Y plus 2 squared. We see that? -4 times 5. -20. Which hand is that? B? Looks like B. Am I missing something? Yeah, it's B. Question, comment.
Couldn't you also find A from using the directrix?
Yep, you could. It's going to be, that's right. So to go from 1 to 6, that's 5 away also. That's right, good job. So it's 5 either way. Yeah, so the A is how far to the focus point or the directrix, either one. Those are always the same.
So, like, if you didn't know the focus point, you could still find A if you had the directrix.
That's right. You sure could. That's right. Yeah, is that good? Everybody with that observation? That's correct. It's always from the center of the parabola to either to the focus or directrix, same. It's A either way. That's right. So A is 5. So there's our equation. Good on that? Questions on that? A lot of details to these things, huh? All right, so there we go. Y plus 1 squared is 6, x minus 5. Y plus 1 squared is 6x minus 5. Okay, so they want us to graph it, you know, and find everything in the world, the vertex, focus, directrix, whatever. Get the graph and get all the other stuff. So let's get the graph. So what do I have to do? There's like a trick I have to do. Do you see it? Let me ask you this. What look do we have to give the equation for us to graph it? Let's look back. Look with me at these. See how these all look? Are you getting? It's probably worth a minute for me to just say, do you see how math and science play this game all the time? Where you have to, I call it plastic surgery to help people remember. We're removing the wrinkles, we're giving it a new look without changing the actual value. Same person, different look, right? That's what we're doing all the time in math and science. They give me some kind of equation, and they say, hey, make it look like this. Why? Well, because it's for our convenience. If I make it look like that, and by the way, what do I mean make it look like that? Force a 4. Force a 4 to show up. Force that to happen. If there's not one there already, you make it happen. Give it that look. Force a 4 to appear. Why? Why? Because once you do, if you force a 4, then whatever comes afterwards will be your A, will tell you how far to the focus point and backwards to the directrix line. That's why. Do you get that? You see how we do that? That's not just here. That's like all the time. You go on and take other math and science classes. We're always playing that game. And if you get the hang of it, it helps a lot. It's like half of math and science almost is playing that give it this look or do the plastic surgery game. You take something, you make it look like a certain thing, because when you do, then it's very convenient for what you need to do. You know, if I was a computer, I wouldn't need to change the look at all. I could just type it in however it looks and boom, it could just plug all the numbers in, it's all good. But I'm not a computer. I need help. I need to make it easy. And what makes it easy is if we force a 4, then that next number will be your A, your how far to the focus point. That's how I'm going to find how far to the focus point, by forcing a 4. That's what that equation is saying to us. Are you speaking his language? That's what all math science equations are saying when they give you a certain look. They're saying, look, if you make it x squared and then make a 4 appear, and then whatever comes next will be your A. Will be how far to the focus of the direction. That's what they're telling you. When they give you any math science equation, they put certain letters in certain spots. They're saying, make it look like this, and this thing will be what you need. So I go, okay, I got to force a 4. I got to force a 4. You always have to force a 4. So, yeah, but I got a 6. Yeah, but you got to make a 4 show up. So but I can't change the value, huh? Same person, new look. So how do I do that? I force a 4 and then something else, which will become my A. Everything else is the same. So I'm going to force a 4. I've got to. And then whatever's here will be my A. Well, how do you know what's here? Well, whatever, 4 and the whatever, the A, 4 and the whatever, has to be the same as 6 in the end. I can't change the actual value. It's still got to be 6 when I'm done. That's what we do all the time in math and science. New look, same value. So you tell me it's not really normal to factor 4 out of 6. That isn't something we usually do. How do you do that? 4 times what is going to be the same as 6? Easy way to do it. Yeah, you're right, you could figure it out and be tricky and stuff. But what if I gave you 17 or something really ugly? What you do? Here's the simple rule. You just take whatever number they give you, 17, 6, 20 million, whatever, just put it over 4. Those 4s would cancel. That's 6. Now I'm going to reduce that to be 3 halves, 1.5. But you see the first step? You just take whatever and put it over 4. Simple, right? They give you 17 million, put 17 million over 4. Times 4 is back to 17 million, isn't it? See, these 4s would just cancel. That's really just 6, isn't it? See the game we play? That'll always give us the look we want and still be the same value as it was. So you just whatever number they give you, who cares? Just force a 4 in the front and put their number over 4. And you really have changed the look without changing the value. Now, we don't want to leave 6 fourths. I would divide that on my calculator. It's 1.5. So let's just make that 1.5. Now, why have we done all this? Because that tells me my A, doesn't it? That's how I know how far to the focus point and how far backwards to the directrix line. That's very helpful to us who need to graph. That's why we force that look. All the time they're playing this game in math and science. Half of what we do is that kind of a game. All right, can you graph it from there now? graphing. Start with the center. Find the center and locate things. Give me a second. Feel free to shuffle those around just see if you get the same answers.
No, that's not the no, actually. Yeah, I'm looking at this one. Yeah,
Yes,
that's a good.
right. And yeah. Three and a half? Yep. Total.
No,
And you would say that's
1.5.
hitting the x-axis, so it's x equals 3.
Because
Yep.
if you look at
Good.
here, this equation, the a is 5.
Oh, yeah.
So, yeah.
Well, what is it?
Getting it okay?
1.5,
So let's go to the graph here.
direction.
So the center, remember it's opposite. So that'd be over 5, 3, 4, 5, down 1. Like there. Is that good so far? So over 5, down 1. Remember it's opposite of whatever's in the parentheses next to x and next to y. Over 5, down 1. Okay. And now, is this one going right, left, up, or down? What tells you that? Yeah, the first power letter, and what sign's in the front? Positive. Positive x to the first, to the right. Going in the positive x direction. Everybody see that? It's always that's super important, that if you get the direction wrong, everything falls apart. You want to be, that's why you want to have on your 3x5 card, this, wherever it is. So you say, oh yeah, positive x on the right side, yeah, that's to the right. So we're going to the right, positive x direction, going to the right. Okay, so now how do I find the focus point? How far is it to the focus point? That's why I did that whole force the 4 out thing, 1.5. So you just go, okay, here I'm at over 5. So if you go 1.5 to the right, you're going to be at 6.5, aren't you? So this must be this is the focus dot right here, which must be over 6.5. It's still down 1. That part hasn't changed. The height doesn't change. It's just over 1.5 to the right. Everybody good with that? 1.5 to the right. I'm kind of running out of room here. This dot here is. And then where's the directrix line? So if this one's at 5, you take 5 and you subtract 1.5 and you get 3.5. It hits the x-axis at 3.5. Right here. At 3, it's 1.5. It's 1.5. See, I subtracted 1.5 from 5. And here I added 1.5. So I took the center, which was at over 5, and I added 1.5 for the focus, subtracted 1.5 backwards for the directrix line. And we're done. We got everything they wanted. They're not asking for the Latus Rectum. Good thing. Questions I can answer. Is that making sense? So you find that center dot. So the easiest way, let me make it easier. You find that center. Well, that's about as easy as I can make it. You just find that center dot at 5, and you add 1.5, so it's 6.5. And you subtract 1.5, so it's 3.5. It's x equals 3.5 because it's hitting the x-axis. This is the x-axis that the line hits.
And the direction, we take it from the 4.
It's positive 4, x to the first.
Okay.
So positive x to the right. Range gears, again, this is one of the hardest sections in the course. It's really thick with material. So here's the deal. I'm going to give you the recognition, a lot of the battle math recognition. Something you got to recognize here that we haven't seen. This will be brand new. When you see y squared and y to the first, or x squared and x to the first. You got to do a whole special process. So this is for sure on your 3x5 card. This will be really helpful. Recognition is a lot of the battle. Is when you see y squared and y to the first, or x squared and x to the first. What do you do first? Get the y squared and y to the first alone. Get them alone, first off. So I'm going to grab this 3x and grab this 25 and move them to the other side. So I have y squared minus 10y is, minus 3x. Oh. Minus 3x minus 25. Good so far? Okay, wow, what are we even doing here? Well, yeah, I'm doing fancy plastic surgery here. I really have to change the look. Let me show you. What do I mean change the look? Look with me back at the last one for just a second to see where I'm going. See the look of it here in the end? What did it have? Parentheses squared. And the other side, also parentheses, huh? So, in other words, the look, our goal, the look we want in the end is y plus or minus some number squared is 4 times a x plus or minus some number. Yeah, maybe that's the most helpful thing I could do, is just say there is the look you want in the end, the format you're going for. We have to take what they gave us and make it look like that. Why? Because that helps us graph. It's really just for us. Again, if I was a computer, I could just type that in and say graphic computer, and it can do it just fine. It doesn't need any special look. But I do. I need help. I need it to look like this so I can look here and say, oh, opposite, opposite, that's my center. Look here, go, oh, that's my focus point. You know, I need that look to help me graph. It makes it easier for me to graph. So I've got to take what they gave me and make it look like this. Well, how do you make it? That looks considerably different, doesn't it? What do you have to do? You got to make squared on a parenthesis and parenthesis on the other side also. How do you do that? How do you make squared on, not squared on just one letter, but squared on a parenthesis, notice? How do you make squared appear on an entire parenthesis? Well, you do something which you remember perfectly from algebra, I'm sure. You got to complete the square. That's what this is called. This is a squared format. Parentheses squared, that's squared. You've got to do, what we're doing over here is called completing the square. Does anybody remember it at all? Any part of it? There's a certain number you've got to add. There's a magic number that'll make it happen. How do you find that magic number? And the hush falls over the crowd, huh? It's this middle number right here, divided by 2 and squared every time. It's middle number over 2 squared. Add this to both sides. In other words, let me bring it up here. I'm going to take negative 10 over 2 squared, which is negative 5 squared, which is positive 25. That's the magic number for this problem. Add 25 to both sides. By the way, it's a pure coincidence that they happen to have a negative 25. That's just total coincidence. That'll probably never happen again. So don't think that that's always going to match. It won't. I wish they hadn't done that. It makes it look like it does. It does. Pure coincidence. So is everybody good to this? Everybody see what's happened? I found a special number, a magic number, that will complete the left side. It'll make the left side factor. Now, why do I put it on both sides? Why don't I just put it on one side? Because it's brand new. Anything that you bring in new that wasn't already there, you've got to bring in with balance, huh? Left side and right side, so you don't change the problem. Is that making sense? See the difference between the black negative 25 and the purple positive 25. The black negative 5, he was there from the beginning. He was positive 25 on the left side in the beginning, and I moved him to the right side, so now he's negative 25. He was already there. I didn't bring him in new. But the purple 25, that's new. I brought that in new. That's why I had to do both sides. Everybody see the difference? Something new must be done with bounds, so you don't change the problem.
So wait, does that get rid of the negative 1?
No, it makes the left side factor two parentheses that are exactly the same. It guarantees that that will happen. So let's do it. Let's factor that left side now. Why? What two numbers multiply to be positive 25 and add to be negative 10? What times what is 25 and adds to be negative 10? Negative 5, which means it's y minus 5 squared. See how it did it? It made that left side a square. You see that? It'll do that every time. That number is the completing number. It's like they used to say in the olden days. Remember the olden days when they'd say, your spouse completes you? My better half? Nobody talks that way anymore, huh? My sweet little wife completes me. So completes, right? Completes your life, that kind of thing. So that's what the little 25 does. That 25 that we add to both sides, that completes the left side, makes it factor perfectly, just like it needs, right? That's what that left side does. So on the right side, it does whatever it does. Who cares? No guarantees what's going to happen on the right side. It happens to cancel out. Pure coincidence. So the right side's minus 3x. We've got the look we need. That's the look we need. Does that make sense?
So that's the vertex?
Yeah, so what is the vertex? What is the center, the vertex of this shape? It's opposite of the number added or subtracted next to y, and opposite of the number added or subtracted next to x. What number's added or subtracted next to x? 0. 0, positive 5. Must be the center of that U shape. Now we know the center. This making sense? That's also, by the way, why there's no parentheses on the right side. Because if I was you, I'd be administrator. You just told us up there that we need parentheses on the left and the right, and you've got no parentheses on the right. That's right, because it's 0. If it was any other number added, if there was anything else added or subtracted next to x, I would have to do parentheses on that right side. Really, if you want, if you don't have to do this, but you could say it's x plus 0. I mean, that's silly, but that's true. If you want to do that look, all right, there you go. There's a look. That's what it really is, right? That's still the same, right? X is x plus 0. I haven't changed any values. So if that helps you do that, whatever. That's what it really is, right? So there's parentheses on both sides. Good. But we got a little bit more to do. We have to force the 4. We still have to force the 4. So let me erase this stuff. And let's force the 4. So where are we at? We're at y minus 5 squared is minus 3x plus 0 minus 0, whatever, same thing. There's no difference between plus 0 and minus 0. It's just 0. So now, can you do one more step? Remember, we don't quite have the look we need. We need to force a 4 out there. Can you force a 4? Make that 4 appear. Let me let you do that. We've only done that once, so it'd be good practice. So force a 4. Oh, actually, it's going to be minus 4. Whatever sign is in the front, you just keep it. You know, if there's a minus in the front, then it's minus 4. If there's nothing in the front, then it's regular 4. You just follow the lead of whatever's there. So it's going to be minus 4 times what to really be the same value as 3. So what's it got to be? Yeah, remember you just take whatever they gave you and you just put it over 4. Right? Because those would cancel. That's really minus 3. That's just a fancy way to write minus 3, isn't it? And why do we do that weird fancy game? Because then we know what our A is. Don't we? Now we know what our A is. A is 3/4. Or if you prefer, just make it 0.75. I think decimals are a little easier. 0.75. 3/4 of a dollar. 25 cents. Is that good? So that's the look we needed. Now we can graph it. I don't know if we have time there. These are long. They want us to do everything in the world. Find the vertex, find the focus, maybe we better. All right, can you do that now? So now we have the total equation we needed. It's got the look we wanted. can you graph it from there? Find the center, find the focus, find the directrix. Bless you. So you want to do that? Let me go to a fresh screen if you got that copied down. So go ahead and make a graph there. Go ahead and make a graph. Start with the center. Put the center dot, then decide if it's going up, down, right, or left. Find the focus point. The focus point's going to be 0.75 away, isn't it? That's what that A means. That's why we forced the 4 out. Focus dot will be 0.75 away. Yeah, so the focus point will be 0.75 inside the shape, and the directrix line will be 0.75 behind the shape. So here's the center dot over 0 up 5, right? Opposite, over 0 up 5. There's the center of the vertex. Is the thing going to open up, down, right, or left?
Left.
Yeah. Negative x to the first, huh? It's going left. The negative x direction. The direction of the negative x-axis, right? This is the negative x-axis, positive x-axis, right? On that? Yeah. Because it was a negative back here. See how there was, when I took that 3x originally, moved it over, became a negative 3x. I just moved it to the other side. So that's the first step. Oh, I erased those steps now. But that's the first step when you've got y squared and regular y, is to move everything else over, become a negative 3x. Yeah, when I write this, I mean plus or minus 4, depending on whatever sign you have. Yeah, so we ended up, so I had negative 3. Oh, this is messed up. This is supposed to be 4 here, isn't it? There we go. Thank you. Negative 4, yeah. So yeah, just whatever sign you have in the front. If you have negative, then your 4 is going to be negative. If you have positive, then your 4 is going to be positive. So that's why we ended up with, oh yeah, that's supposed to be 4, huh? Not 3. I'm messing up. That's supposed to be 4. Whatever. I'm ignoring it now. Once that 4 is out, I don't care about it anymore because I'm just focused on the other number. But it was 4. It's always 4. We always force a 4.
Oh, yeah.
Right. So good. So there's the center. It's going left. And how far is it going? 0.75. So the focus will be here, 0.75. So that's subtracting 0.75. So that'll be back 0.75, up 5. And the directrix line is over here. And that's hitting the x-axis at positive 0.75, right? So here's the focus point at negative 0.75, up 5. We're done. That's all they wanted. Are we happy with that? It's a lot of steps, isn't there? There's a lot of little details on these. You can master these if you give them hours and hours of your life. You got no other plans for spring break, right? Questions? Anybody going anywhere really exciting? Got fun plans?
Homework, my dad is pretty excited.
Go home, so far away?
No, home is pretty. Going to
Pismo area, that's fun.
Yeah, visiting my grandmother.
All right. One of my students in my other class is going to London because her husband is a pilot. So must be nice. Yeah. All right. All right. Okay, so y squared minus 4y plus x is minus 5. All right. Now, I don't know if you caught the tag or not. how are you going to recognize on the next exam, and there for sure will be one of these? No secrets with me. I want you to know what I want you to know. There will for sure be one of these where you have to complete the square. How are you going to recognize it? What is the mark? That's almost as important as the steps. How do you tell, oh, this is one of those where I got to do that whole add the magic number, parentheses squared stuff? If there's x squared and regular x, or y squared and regular. So that's the mark. So make sure you know that. Let me put that down. If you see y squared, so if you see y squared and y to the first, or x squared and x to the first, that's the mark that you have. See how we see y squared and regular y? Then you go, oh, that's one of those. Now let me show you. Let me go back and compare and show you that that wasn't on the other problems. That's a lot of what I'll do as much as I can in our 2 hours twice a week with that, but that's what you need to do for yourself. That's how you master math and science. You got to spend time looking at homework, and not just that one, but then look at the other ones and go, oh, I see, and you got to compare and contrast. And you go, oh, let me show you. You got to do like, you see, okay, y squared and regular y, then you look back and you go, let's see, see, now look at this one. You think, this one we didn't do that right. He already had the parentheses. The only y I see is right there in a square. I don't see like a y squared separately and a regular y separately, do I? I just see one y in a parentheses squared. And I see one x, right? Not going to do that special process. And that's how they all looked, all the other ones. You see the difference in the look? That's what I do that when I can. I have so much time though. That's what you need to do for yourself, is more and more compare. That's what that practice exam is for, is just to compare and start to do, oh, when it does this, I do that. And then have those steps on your 3x5 card. When I see this, I'm going to do these steps. When I see that, I'm going to do those steps. That's math and science, a lot of it. So when you see this, you go, oh, there it is. Got to do that special thing. Okay, so what are those? What is that recipe for making those cookies? What's the first step when you see this? Get the y squared and y to the first alone. In other words, ditch everything else to the other side, which would be this x. Jump him to the other side. You want the y squared and the y alone. So that's the first step, right? Get that alone, and then find the magic number to add to both sides, right? So I add that. So it's going to become negative x, isn't it? When it jumps to the other side. So step one, get the y squared and the y alone. We did. Step two is find the magic number, which means what? Middle number over 2 squared, add to both sides, right? So take the middle number. What's the middle number? That negative 4 or 4. It'll work the same either way. It doesn't matter. We're going to square it. It's going to be they're always going to be positive in the end because we're squaring them. So it doesn't matter if you don't get the negative. It's all going to be positive in the end because we're squaring them. So you're going to take half of that. Half of 4 is 2. Squared, 4. Positive 4 though, because we squared it. So we're going to add 4 to both sides, aren't we? Over 2 squared, which is negative 2 squared, which is positive. So I'm going to add 4 to both sides. Everybody tracking with me? I add 4 to both sides. What will that do? That'll complete it. That'll allow the left side to factor as the same parenthesis twice, in other words, parenthesis squared. That'll make the left side a parenthesis square. That'll complete the square on the left side. Right? Y minus 2, y minus 2. What's the other side? It's minus x minus 1. Good so far? So what's the look we're going for here? What do we need? The left side needs to be parentheses squared. We got that. So we're kind of done with the left side. That's all good. The left side has the look we need.
We need a 4.
What about the right side? What do we have to do on the right side?
4.
We do need to do a 4, but before that we got to do the parentheses. Yeah, this is why I wanted to show you this one in particular. Last time we didn't need parentheses, so this one has one extra little wrinkle. Did you want that? One extra? So the right side, you've got to get parentheses first, then the 4. So don't worry about 4 right now. First, you've got to make there be parentheses, right? We need parentheses on both sides. Right? You know what I mean? Let me compare. This is what you should do for yourself when you're doing homework, trying to learn. You should go, wait, what happened on that last one? Why didn't I need to do that there? On the last one, if you look back, we just had, see these canceled, and I just had minus 3x. And so the way I made parentheses on the right side, I said, well, x, that's just x plus 0, or minus 0, whatever, same thing. Right? There's no number added or subtracted, so it's just 0. But I still made parentheses. This time, I have a number. It's not 0. Added or subtracted. You with me? I'm not talking about a number in the front. Like, I don't care about that minus 3. That just stays in the front. Whatever. Later becomes a 4. I'm talking about numbers added and subtracted right now. Right? That's what the parentheses are all about, right? Parentheses are all about numbers added or subtracted. So what do we do with this number subtracted? Well, you've got to make it be parentheses, x, something in the front, something here. That's the look you must give it. And we'll do the 4 in a minute. But let's just first get the parenthesis look. So how do you do that? What number's going to go here and what number's going to go here, add or subtract or whatever, to make it really be the same value as really be minus x minus 1. We're not changing any values at all, just changing looks, right? How do we make it look like this, but really still be minus x minus 1? What goes in the front? Negative. Yeah, you just factor, huh? You factor out negative 1. And what's going to go on the inside to make it really still be the same as minus x minus 1? Positive 1. So everybody see that? If I was to multiply that, that's really minus x minus 1 with the look we need. Now force the 4. Everybody see that first step? You've got to factor the right side, don't you? You've got to take off whatever's in front of that x so you can have parenthesis x. That's the look you need on the right side. You see that? Now what do? Now you got to force there to be a 4. So make that into negative 4 and something, and x plus 1. And we'll finally have the look we need. So last step in all this change the look stuff. You got to make it, why negative 4? Because we already have a negative. Whatever sign's there, if there's a negative there, it's negative 4. If there's no sign there, it's positive 4. Negative 4 times what? Times x plus 1. That's what we're talking about, right? So negative 4 times what? Times x plus 1. So minus 4 times what will be the same as minus 1? Because minus 1 is really what's in front. So I got to make it look different without being different. So minus 4 times what? 1/4. Right? Remember, it's always just this number over 4. Because that's still a negative 1, isn't it? It just looks different. Did y'all see that? Can't see it now. Questions on that one? So yeah, and you would have to graph. I'd like to move on if I could. Right, you could do the rest from there. Right, this is our A. You would graph it, find the center. This one goes left. Find the A. Blah blah blah. Is that okay? We just have so much time. All right. Word problems? Was that in your mind?
There's a lot to this set.
All right, now let's work one backwards. So this time we're going backwards, meaning they start with the picture, they want us to come up with the equation. So I think this should be a little easier. So which one of those is the right equation? Let me let you think about that. Give that a try. Oh, that was pretty easy. You know, we could do that one easy. Without getting into all the details, we could do that one by just saying, look, is this one going up, down, right, or left? Up. So positive y, that means it's going to be positive 4ay. X squared is positive 4ay, right? So, for C, for D, because they have minus signs. That'd be down. That's not right. This one's going up, isn't it? So, two of them are out. So it's either A or B. Either A or B. And we can find it by, what's the center? Right here. 0, 6. So opposite of 0, that's just 0. Opposite would be minus 6. Remember opposite? Minus 6. A, done. Now why is there a 9 and all that? Well, just because you could find it. Find A, blah, blah, blah. We got word problems to do, so I'm going to go on. Is that good? Does that make sense how we found that? All right. Very, very commonly used in real life, engineering and science. So satellite dish is shaped like a paraboloid of revolution. That just means a 3D parabola. Because a parabola itself is just two-dimensional, right? So whenever they talk about like a paraboloid, they mean you learn that in Calc 2. You take something and you rotate it and you make it into 3D. So if you take a 2D, two-dimensional parabola, and then you do this with it, you make it into a 3D parabola dish. So that curvature is called a paraboloid of revolution. You revolve it that way. So if you go into Calc 2, you take integrations of revolution. So find areas and things like that. So anyway, satellite dish, it's basically a parabola, right? Because remember, remember why it works that way. That the curvature is curved just right so that it's got a focus point, it's got a receiver that it holds, so that any incoming satellite beams bounce right to that receiver, don't they? All the curvature is aimed right at the focus point. It's focused right at the focus point. That's how it works. Okay, so what? Well, they want us to find out, how do engineers know exactly where to put the focal point, the receiver? They got to know where to put it. They don't just guess. How do they know? Well, let's figure that out. They're saying that the dish is 12 feet across at its opening, so that means the mouth is 12 feet, and it's 4 feet deep at the center. Mine doesn't look like, my 4 looks as big as my 12, but whatever. So we got a satellite dish that's 4 feet deep at the center, 12 feet wide at the opening. Where do you put the receiver? Where does it go? All that curvature is going to aim up at some focus point. Where? I mean, like how far, question mark, how far is it out to where you should put the receiver, the focus point? It's aiming everything at what exact location? For a 12-foot wide mouth and a 4-foot deep satellite dish made of parabola shape, how do you find it? What do you mean, like, it's not going to be right here at 4.
That's 6, right? That's 6 over.
Oh, it's going to be somewhere on this line, if that's what you mean. Yeah, it's somewhere on that middle line. That's true. Yeah, absolutely. It's just a matter of how far on that line. Yeah, totally. It's somewhere on that line, but where on that line? How are we going to find it? Yeah.
Would it just be half of 4 or no? It wouldn't be that easy.
No. That'd be nice. That'd make the math a lot easier. It's just half. No. So how do we find it? Think with me. This is a good time to see how math works with real life here.
Would that be the vertex right there? Consider the vertex?
Yeah, the vertex is always the center of the shape right there.
And then,
That's the vertex. We want to find where the focus is.
so that would be the Directrix line? That's
No,
what-
the Directrix line is behind it. So we got to find where the focus is. So how are we going to do that? Well, what you could do is some really fancy, hard geometry, which I can't do. I don't know that much geometry. Right? You could use some fancy geometry about shapes and curvature and how that curvature is in bouncing lines, and I'm sure it'd be interesting, but it'd be super hard. Well beyond my geometry ability. You do that, or you could do analytic geometry, which is much easier. Now, what is that? What is analytic geometry? When they say that phrase, analytic geometry, this is a good point to make to give you the idea of what we're doing here. Analytic geometry means algebraic geometry. Analytic is, I don't know why they use the word, they can just say algebraic geometry. Means that's what chapter 10, this chapter we're doing right now, parabolas and then ellipses and hyperbolas, that's what it's all about. What do I mean? It's about taking geometric shapes and putting them on an axis system so that you can use the equations, x squared is 4ay, y squared is 4ax, that we've learned for axis systems. In other words, what I'm going to do is I'm going to take this satellite dish thing and I'm going to put it on a made-up axis system. See how math works with the real world? Remember, math is made up, right? When you look at somebody's satellite dish on their roof, you don't look at that and go, oh, I see the axis system. No, there's no such thing. If you're seeing one, you're seeing imaginary ones. Maybe you have some imaginary friends too. Right? No, there's no real axis system there. Right? We're just making it up. Why? Why do we make it up? Because that makes the math easier for us. You see how that works? So what I'm going to do then is I'm going to take the question they're giving me with the paraboloid thing, and I'm going to say, look, I'm just going to put it on an axis system going up. Now, I could have put it on an axis system and had it going right. Who cares? It's just all made up. Do whatever you want. If you prefer right, do right. If you're up, you go down or left, but I don't want any negatives, so I'm not going to go down or left. Sometimes I do them up, sometimes I do them right, whatever. I'm just going to do this one going up. But remember, that's all made up. There is no such thing as an actual axis system there. But when I do that, it makes the math easier for me. You see? See how math works with the real world? We make up these things that help us do real life things. All right, so here we go. So, okay, if I do it like that, if I make it up, I could have made it right. You know, I'm just making this up as we go here. I made it go up. So what? So what if you, for one going up like that, and I centered it at the origin, just because that's easy. I don't want to put it anywhere else but centered at the origin. Numbers are easier. What's the equation when you're going up like that? It's positive y. So it's positive 4ay. It's x squared is positive 4ay. Good, it's going up. First power letter is positive. Right, the center is 0, 0. So because I made it 0, 0, just for my convenience. Right? So that equation produces that parabola, doesn't it? Okay, great, I get it. All right, you're probably thinking, all right, I get that. So let's stop for a second. What are we trying to find? What do we really want? We want to know where the focus point is, right? That's what they're asking, is where do we put the receiver? What's that in the equation? A. All this about our goal is find A. If you find A, you're done. Right? A is where the focal point goes. You see how convenient this is to have these little equations that have an A already built right in? So we're trying to find A, which is where the focal point is. All right, so how do we find A? Well, you tell me. It said the opening is 12 feet, and the depth at the center is 4 feet. Yeah, you're looking at some points, huh? Exactly right. Yeah, do we know the coordinates, say, of this dot right here? Do we know the XY coordinates of that dot? How far over to that dot? It's 12 all the way. Must be over 6 and back 6, right? So it's over 6, up 4, because it's 4 up. This dot must be the dot 6, 4. So what? Well, that's XY. I can plug 6, 4 into the equation. It must make the equation true because it's a dot on the picture. It's a dot on the graph, a dot on the shape. So you got to make the equation true. So plug in the 6. 6 squared has to equal 4 times A times Y, which is 4. In other words, 36 has to equal 16A. I can solve for A. Just divide by 16. Isn't that 2.25? Yeah, 2.25. There it is. We're done. Where does the focus need to go? 2.25 away from the center. Right? This distance right here has to be 2.25 feet. That's where you locate the receiver. Everything will be aimed at that point, 2.25 feet from the base. So it's all about finding the A. That's the focus. Questions on that? Is that making sense? See how this made-up axis system really helped us?
Couldn't we use the 12?
So this dot from the origin is over 6, up 4.
Oh.
Right? Because it's 12 all the way.
Okay.
So half is 6. Does that make sense? Right? Because they said the mouth opening from here to here, they said, is 12. So from the middle, over is 6, up is 4. This is the point, right? Because whenever you do coordinates, You start from the origin, don't you? Start from the middle, over 6, up.
Let's say they gave us a big number. Can we just like divide it by 2 and then?
Right. Is that good on that? All right.